Hello. How is going? The audio is okay. I'm testing a different microphone. Testing a different microphone. 1 2. Good evening. How is the sound? Because I'm testing a different microphone. Hopefully it's going better. Any input from you about the sound? Or shall I switch the one that I used last night? Sounds good to me. A little echo. Maybe because I have the laptop that he was playing back the words. I reduced the volume. So hi Nick. Hi Adrian. True honest SMD versus true hole. Do you sound different in an amplifier of some sort? Depend. I prefer the class A or class AB amplifier to use the true hole components. And class D definitely you can go with SMDs. No any problem. Right, let me bring my beer because I forget it on the fridge. And we're gonna start to build these two short finders. Usually my bottle opener is a screwdriver. Where are the guys like J Fix, James, the other ones? Did they watching someone else live stream? I'm having a cup of tea. I had a tea before dinner. We had dinner, me and my little boy. And we had a cup of tea before around 5 o'clock, something like that. Then around 7 o'clock we had dinner. Then I put him in his bed. He have the tablet. If I might need anything else, I'm gonna might go to check on him time to time. It's fine. I put on this side here the chat. Thank you. That's exactly what I said to a friend of mine. Yeah, AB or A, true hole definitely, because it will gonna generate a lot of heat over there. So class D that is running cold is fine with SMDs. So cheers, guys. So let me change the camera over here. And tonight we're gonna build two of these guys. They are short finder pulse injector voltage, and looks like two subscribers are interested to have as well, so I can build more 3 PCBs. This is what I have. If in case I'm gonna get more requests, I'm gonna definitely build more of them. I'm gonna order more PCBs and I'm gonna build more. So the one that I'm gonna build tonight are those ones, and I need 2 battery chargers, 2 batteries, the 2 microcontrollers. Where they are? Over here is one, and here is the second one. I'm gonna need this one to stick the battery at the back, and I have here the other bits and pieces. So how you would like me to build? Because I have three options. Using the soldering station.
Ayan.
Okay, just change it here to say hi guys.
So, ayan.
Say hi guys.
Hi, I am Ayan.
Okay, you have an Ayan. Okay,
Wow.
just go. Sit on there or go in the other, but put the volume low, only if you stay here. Wow, my little boy come to visit me. Really need an option to disable the beep on the short finder. Okay, you can just desolder it for now. I'm gonna do another button. Okay, so I'm gonna do another revision. I will not order any more these boards. I'm gonna do another revision. I'm gonna add on the software another button that you can disable and enable the beeping. It's a good input, no any issues. But for now on this version, you can just desolder the beeper and that's it if you don't want a beeping. But in this case, I'm gonna do another revision. I'm gonna work on the software to add an extra button that you press one, you activate, you press again, you deactivate. Or I can don't use on software. I can add another switch in series with the beeper over here and do the same. Alright, so I was saying that I have 3 options on building these ones: soldering station, hot air station, or solder paste and using the hot plate. So which one, guys, do you like to see me doing? Huh? Which soldering technique? Soldering station, hot air, or hot plate? I'm gonna go through these parts to make sure that I have everything what I need. On doing fast, each button is generally easier to manipulate. Yeah, I can add another, I can redesign the PCB board and add another switch. I choose. Okay, so I'm gonna might do, because the hot plate is quite big to put on the table and it's sitting just there at the back. I'm gonna do one fast with the soldering iron, and I believe that I'm gonna do the second one with the hot air. Okay, so let's start the one with the soldering iron. Alright, so these through hole things, they are gonna go the last one. So first I'm gonna start with the SMDs. So let's begin with the resistors first. Let's begin with the resistor first. So I put there the ones that can go on this build. So I need a good pair of tweezers. I need my soldering station over here. I need solder wire, tip cleaner, soldering iron bits. Which one to use for this build? Which iron tip? Which iron tip? Let's try this one, which is a bit bent like that. I'm not too much fan of them. Let's see how it's going. Otherwise, if it's not going well, we're gonna might changing along the way. Not that much good on this one. Maybe we use this one. Maybe. Let's start with this one, and then we're gonna see. Then we're gonna see if I need to change the iron bits. So that's done. Let's turn it on. Okay. I say tweezer. Let me also go through the chat. You need the solder iron in any case, not all the parts of surface mount. Yeah, the solder iron is gonna go also through hole and everything. You are using only type key. Well, it depend of which jobs I'm doing. I'm always changing them. Changing them depend of the jobs I'm doing. So I'm gonna start with this 5K resistors. So let me get the 5K resistors over here. They can be also 4.7. It's alright because it's a digital thingy, not analogic, so it's just pull up or pull down the thingy. So we go to switch to the microscope, because actually I can do it also like that, but I want you to see when I'm soldering. So let's bring this guy over here. Lights on. Lights on. Need to bring it down. Something like that. Let me switch to the microscope. And let me give 2 buttons over here. And we're gonna go, I say, with the 5Ks first. So I need to add a bit of solder to one side of the pads. So let's go. See, that's why I don't like too much the K-type. That's why I don't like the K-type. Another 5K there. Right. Now let's solder them in place. So I need to get the resistors let me open them. Hello James, hello Ice Squishworm. You joined me a bit late, I already start. I already start from long time, man. Okay. I start already. I was breaking laptop, lol. No problem, you can fix it. You get a spare motherboard from eBay and you can fix it. Definitely. I'm sure that you're gonna fix it. I'm pretty sure you can fix it, don't worry. Hey, all of them upside down, man. Yeah, let me get more resistors out from this resistor holders. How many I still need? I need another 3. Okay, 3 more. Three more. Three more. To go. That's one. Sorry guy if I'm quiet, I'm focusing on what I'm doing over here. Soon I finish this resistor, then I'm gonna have a look on the chat. And I'm gonna see what the people say. I'm focusing on putting these ones here. Opposite. Opposite. Alright, let me have a look on the chant. I was breaking a laptop, I already read it. You are supposed to repair them. I'm confident once you will fix it. Yeah, for sure. So is practice laptop, everything is good. Black color PCB looks nice. Yeah, it's a black matte, I really like it. I had also other black PCBs from other manufacturers, but are shiny black, are not matte. What else is say there? Stream the build. Yeah. Okay guys, cheers. Well, let me turn it in the other side and do also the other side soldering. Do the other side of soldering. Then I'm gonna remove a bit of solder from that pin over there. I don't like too much this type of iron tip. I prefer always the other tips, not this one. Okay, let's remove that big bulb of solder to the first one. That's right, look all nice. Well, shall I give a clean to this one quick? And like that we go further with the next ones. So let me get my alcohol. Let's get the brush. Where is my other nice brush over here? Disappeared, oh man, no. My other nice brush disappeared. Need to find it. Let's give a quick clean on those. It looks good. Let's use also this guy, the nice sponge. Wipe a bit there with the sponge. Some alcohol and wipe a bit good. Good. Next, I'm gonna do these two that can go up to 1.2K. So the lower resistance, the LED will gonna shine, will gonna be brighter. Higher resistance will gonna be a bit more dimmer. So I prefer to be more dimmer, like that the LEDs, they will not blow up fast. So I'm gonna go to 1K. Let's see, 1K. Yeah, let's do 1K. Let's do 1K resistors over there. But first, let's put solder to one pads. Solder to one pad. Let's get two 1K resistors. I thought the LED, they were gonna not be too much brightness. Where is my clean a bit the tweezers? Right. Let's go to 1K resistor over there. Let's get the second one. Anyway, I need to do a second revision on this board to eliminate the diodes, because the diodes there, when I was running the testing, I was powering everything from the same power supply, and looks like powering from the device with the battery, the MOSFETs, they don't like the diodes. They are not switching off because of diodes. So there were the diodes here. I need to run some jumper wire, and the next revision on the PCB board, I'm gonna eliminate the diodes from the PCB. So let's solder also the other sides of the resistor. these two over here. Right, quick clean. Next, I have other two resistors over here, the 20K, that are on the gate of the MOSFET, which are doing the pull down the gate. As soon the voltage disappears from the gate, to switch it off fast, switching to go fast. So let me get those to the 20K. Get two. This 20K, yeah, 20K. One and two. Right, let's put solder in one side of the pods. So I'm using the soldering iron at 350 degrees, just to let you know. And I am using a YCS S1 soldering station, if anyone interested on which tools I'm using. So it's a YCS S1 160 watts that you can use two kind of handles, the T245 or T210. Right, those are looking good. Oh, forget to press it a bit down on it. Good. Now let me solder also the other sides. So go quick to the other side. Looking good. Quick clean. Quick clean. All right, let me go a bit through the chat because I miss lots of things. So James said that he's struggling to take components out of a package. I had problem before they even reach the board. Oh no. How you fix the laptop in this case? I think you fix at least 2 laptops. Yeah, he's doing well, James, don't worry. He's doing well. Right, what else is there? I can recommend you some SMD practice kit if you want. Yeah, I had also some. I was doing some this SMD practice kits, but I suggest him when he go into this BGA things to get some broken boards from laptops or from consoles or from this, how it's called, modem routers, and try to play with the components on the board. And definitely he's getting better. Guys, 1 second to check my little boy. is good. Okay, so now let me find proper calibrated wire for instead of these diodes, because I say with the diodes in, the MOSFETs won't switch off. We're gonna stay only continuously on, because when I tested with the diodes, I was powering everything from the same power supply, even the microcontroller and everything. So when I realized that I put the battery, they went switching off, and I say, what's going on over here? Why they are not switching off? And then I realized that it's giving it a negative voltage from the battery, bring it back to the gate of the MOSFET. So I need... Oh, everything is falling down. Jelly fingers, man. Everything is falling down from my fingers. I have jelly fingers. Look, everything is fall over. Mass. Ah. Did you ever had jelly fingers? You ever had jelly fingers? Right, let me prepare two proper calibrated wires to put instead of the diodes over there. Right, I prepared the proper calibrated wire. Let me do also this one over here, this one over there, this one there, this one there. Proper calibrated wire over there. From there to there. Right. Let's do also the other one, the proper calibrated wire. From there to there. Right. Also they're a little clean. Sorin will approve, yeah, he approved it. It's a proper calibrated wire. It stands for the 10 amps. Will not happen nothing with that calibrated wire. Now the LEDs down here, I need to put them in. Two LEDs. Only with the LEDs I have always I can't identify which one is positive, which one is negative in these SNDs. On the normal LEDs I know, and this small one, so I need to use the power supply. I need to use the power supply to get my to understand which one is positive, which one is the negative. Let me have a look on the one that I built already. If there is any marks on the diodes to tell me which one is a positive, which one is a negative. Alright, so there is a green mark over there, right? And the green mark looks like it's going to the ground. Alright, so I don't need a power supply. I'm gonna follow the green mark to the ground. So here we have the ground this side, ground this side. So the line, small line, is the positive. So the green side from the LED, I can see there is a green one and a normal one. So the green side goes to ground. Right. Right. Let me find the LEDs over here. And let's get the red and the green. Let's get red and green over here. So this one is yellow. This one is blue or green, I don't know. What's the difference? I think this one is the green. No, this one is not the green because it's not missing any. The one that are missing LEDs from it, they should be. So let me see which one is shorter, because all of them are of the same length, apart two of them each are shorter because I already use LEDs from it. So I know which one are red and green. So these two guys, this one are shorter. The other one are different colors. You have a dot on the front, on the triangle, on the back. I need to check that one. I know that the big diodes, the LEDs diodes, how the polarization. But on these tiny bits, I never figure out the polarization. But now I will gonna follow that one. The green part I'm gonna put to ground. So we need to get this one. Which color? This one is the green one, because that's the red one. That's the red one. So that's the red one. That's the red one, yeah. So they're red here, green. So let's do the red one first. Let's pull out slowly one from there. Right, as the red one I say. Let's put a little solder over here. Let's lower the temperature to 180, because I don't want to melt the diode. I don't want to melt the diode. Looks good to me. What about you guys? Looking good there? Looking good to you guys, that the LED soldered in place. Let's solder also the other one, the green one. Looks perfect. Now I'm going the green one. Let's pull out one because they're very tiny ones. Right. Let's put also this one in. Bit more up. There. Just a little bit up. There. Perfect. Right? Now let me solder also the other parts where you are there. Let's solder also that side. Clean the tip, huh? Looks good. Looks good. Cleaning. A bit of touch on this one over there. Yeah. Touch also there. Perfect. Now let me remove a bit this one from here. Let's go to the overhead. Because I need to check some data sheets to see the MOSFETs which I am using, because I have plenty of different models, so I need to use some MOSFETs that are low gate threshold, the voltage threshold. This one are voltage regulators, so I don't need them. Here I have some MOSFETs. Okay, so let me put in the box whatever I don't need to. I finish for now. So we finish with the LEDs, we finish with the resistors. Right. Then let's see where are the MOSFETs which I used before for the other boards. I think I still have only 4 pieces exactly to build 2 boards, and I think it's those one. I think are those one. Let's have a quick look how they call it. See, CRT, and the MOSFETs are CRT. Yeah, so this one is the one that I use it. Gonna use those ones still exactly for 2 boards. And here is a bit tricky. I think these ones I need to use the hot air station, because I need to heat up all that big pot. So we are going to use this. Yeah, we are going to use the hot air station. So let's go back to the microscope. Sorry guys, I'm gonna put these 2 MOSFETs and then I'm gonna go a bit through the chat to have a look what's going on over there. I'm gonna do quick these 2 MOSFETs and then I'm gonna go through the chat. Okay, so which flags do you like? Do you want me to try? So let's put to overhead a bit. Overhead. Okay guys, tell me which flags to try, because last night we used this one. We used this one last night. Huh? Which one to RGB ones? No, are only one color. I don't use RGB. I could use RGB ones, but I need to redesign the PCB in this case. My lens has a little notch in the corner. Have a lab quote. Front in the front triangle. No, just jelly break. Yeah, when I was talking about jelly fingers there, sometimes, you know, I drop things from my fingers and I call them jelly fingers. RGB MOSFETs. No, are the MOSFETs, let's call it CRTD 055N03L. Are very low threshold voltage on the gate. I believe it's 0.800 volts, 800 millivolts, and it's opening the MOSFET. It's very low voltage threshold because the microcontroller over here is 5 volts logic controller, so it will gonna put 5 volts on the gate. So that's why I need the MOSFETs that really are low voltage threshold on the gate, like that they open fast. Amoe. Okay, let's go to Amoe. So Amoe is here. Amoe is here. Let's have a look the Amoe flux how is working. Right, Amoe flux is there. Let me get the syringe. Syringe. Which one to use? I like these models. Right, Amoe flux. No, it's M53. I don't get yet the 50. I don't have the chance yet. It's in my basket because I need to order a few other things. And it's still in my basket. I need to buy a special iron tip, a special, very special one. I need to get also another very special tweezers and few other bits, so it's still on my cart. I still need to add more things there in order to do a nice order with more bits and pieces that I can do. Also a nice mailbag video with bits what I'm ordering. Yeah, let's have a look this flux how it's working. So, whoa, man, why don't tell me it's so liquid? I pressed it like the one from last night. What the heck I did, man? Wow, we need to use just a little tiny. You need to be very sensitive with this one, man. Wow, very liquidy. Very liquid, man. Nah. Let me get it off from there with some Q-tips. I really don't know that is so easy. I press it like the one I used it last night. Man, crazy. Look how many flux I put there. Yes, Greta, what happened? Come here. Come here.
Mr. Sun?
What happened?
Mr. Sun.
Yeah, you want to sit there?
Mr. Sun.
Just sit there. Don't go to the table. No, to the table, no, Greta, no. There is dangerous things. Just sit over here. Sit here. Okay. Sit here, okay? Don't go to the table, please, huh?
Daddy.
Yes.
And this baby.
Which one, the baby?
And this, look in this side
Which side?
Oh, see. Oh, see.
No, I'm working over here. Just play there with the tablet. Greto, there is he's hot. Go to the tablet. Hot, very hot here. Very hot. Say hi, guys.
Hi, guys.
You want to say hi, guys? No. Say hi, guys, to everybody. Say hi, guys.
Hi, guys. How is it?
Say, how are you today?
Yeah, how is tea?
Yeah. Don't go there, Greto. It's hot. Go there, sit on the couch there and play with your tablet. All right, man. Huh?
Sun?
Yeah, but can you put it a bit lower, the volume, because I'm doing. Let me do the volume for you. Like that, okay? Don't put more low, okay? If you want more high volume, you go in the other room, okay? Okay, shake hands.
No, cigar.
No shake hands.
No, this one.
Okay. You can choose which one you like. It's your tablet. Yeah, man. This Amoye, it's really liquidish. You just press it a bit with this. Man, no. This one is harder. You need to press harder on it. Right. Why am I doing a bit of soldering? Yeah. Let's put back to 300 degrees now. The soldering station.
No, or more.
Let's put these pads. Solder. Let's put some solder on the pads. Yeah.
Oh, no.
What happened, Greto? Right. Quick clean. Quick clean, because we make a mess. We make a mess with that flux, man. Well, it's working nice. I like it how he's doing. I really like it how he's doing. The flux doesn't make too much dirt. That doesn't leave too much dirt behind, and I really like how he's doing. Yeah, doing good, right? NanoFix did a video about different flux. Yeah, I saw the video. But the way how he should do the video, he should do to see the different flux, how he's working with different jobs. Like, for example, when you need to do a BGA, which flux is better for BGA? When you do normal soldering, which flux is better for that one? He just do a demonstration like how is the texture of the flux, but that doesn't help you too much, because the texture of the flux is made for special job. Definitely for a BGA chip, when you do a reballing, you need the flux to have a different texture than when you want to solder it, or when you want to solder a normal other QFN, for example. You want to have a flux that give you more tension. How is called that one? That keep the component in place to don't blow it up with the hot air. Yeah, he did a video, but it's not how supposed to do the video. The video should be, as I say, show the different fluxes when you need to solder, for example, BGA, when you need to reball, which flux is better for that job. Like that, you can choose the right flux for the right job. My opinion, boy, if I am wrong, I'm wrong, but my opinion is that one. Because I say, this Amway flux maybe is good for a job that when I want to use this flux for that job, this flux doesn't work like that nice like this one. So that's why he needs to do a demonstration which flux is good for which kind of job. Because I say, not all the fluxes are made it for the same job. Yes, my little boy, yeah. What's that? I don't know. You know, because you are watching your tablet.
You have 80 cabbage.
Cabbage?
Yeah.
Which cabbage?
Yeah, cabbage.
Which cabbage?
What's this?
Oh, put the volume low, Gato. Gato, please put the volume low.
No!
So go in the other room in this case.
Let's have it.
Yeah, go in the other room. Thank you. Sorry guys, that's the life of a father when you are alone with only you and your little boy at home. You needs to do all the things in the same time. Okay, so what I was doing little space on the table to bring the hot air station over here to put those MOSFETs on place. Okay, give me a second to bring my hot air station. Here we go. Hot air station is on the table. Let me turn it on. And let's go 400 degrees because it's not that thick, this board, and it's not like it's not a very thick board. It's not like those motherboards from the computer, and it's not a multi-layer, it's just double-sided PCB, so no need too much high temperature, right? Okay, so let's get these MOSFETs over there. Let me put the board in that side position, that I can keep an eye on my where are the parts? Where is the PCB? There. Here we go. Come in the middle. Yes. And we need to solder this guy over there. Right. Again, a little bit only of Amoe flax. Let's start with this one on the top first. Just a tiny bit, not too much. Gentle press the button. Right, that's more than enough. Let's come with the hot air over there. Oh, a little bit of more flax. A bit of push down. That should be okay. Now let's go to the second one while the board is warm. While the board is warm, let's put the second one. flux. And they should be alright. Let's clean also the area while it's hot. Gonna do a retouch to those pins to the gate and source with the solder iron, and we should be alright. Yeah, let's put some more solder on those pins to cover a bit better also. That looks okay. Looks alright. Looks alright. Looks alright. Alright, looks good. Another quick clean to those pins. Let me change my because that one is already full of flux. Let me get a fresh one. Fresh cleaner. The other one was full of flux. So now this one we can clean better. Alright, then I believe all the SMDs are done. We have the resistors, LEDs, proper calibrated wire and resistor, and the MOSFETs. Shall I give also a touch to the drain? Let's do also to the drain a little touch with the soldering iron. So let me put 350 because need a lots of heat over there. Let's give a bit of better touch also to this one. Yeah, looking better. Looking better. Before passing to the next step, before going to the next step, we touch also those. Right. No, man. Oh, what a job, right? What a job. What a job. And this flux, oh my god, it's very, you know, very sensitive you need to be for the pusher. May. I was expecting that it's not that much liquidish, but it's very liquidish. So, cheers guys. Anyone new over here to say hi? Huh? Anyone new on the chat? What microscope camera you using? Oh, the pic is very good. Okay, so let me show you if I can get to my. I have here a cabinet because I have another one. Because if you see the video when I make the microscope, the company they send me a second one because the first one was not recording on the SD card. The second one they sent me the same was not recording on the SD card. And I'll show you which one is. 1 second. It's this camera. And I have another microscope over here, digital, this one. I tried with this one. I tried with the one that James sent me. No, I can't. If I'm not looking through the objective to see my hands moving, I cannot control my hands. They go everywhere in all directions. So I don't know. Maybe when I'm gonna reach 5,000 subscribers, I'm gonna make a giveaway this microscope to someone. So help me, guys, to get fast to 5K subscribers, and I'm gonna do a giveaway. This complete. It's working perfectly. Yeah, I tried and I tried. I can't. I'm one of those guys. I cannot. So if I'm not watching my hands straight away with my eyes, it's like I feel my hands doesn't belongs to me. Like I can't control them. How should control? So that's why I needed. Because first I buy just the camera with the digital, like the one also I'm pretty sure the one that is using also this Andy. I tried to do a few jobs, I couldn't, and I say no. If I need to a microscope, I need the trinocular. Otherwise, I will not be able to work on. So then I ordered this one. I use the same camera to it because it's the same C-mount attachment for camera. So I take the camera from the objective and I put it to this. I only change few bits and pieces like the barrel lens on the bottom. I order a 0.3 to give me more space from the table to work on the on it, because the one that come on the kit with the trinocular was number 1 times 1. I needed to stay just, you know, maybe this distance from the PCB with the microscope to can see focused everything good. So I say no, there's something wrong. So I did the research and I needed to put the barrel length 0.3, and now I have a distance of maybe something like that under the microscope that I can work. Sorry guys for my cough. Oh, let me clean a bit also my table with a little alcoholis. Where are my wipes? My wipes are behind there. I might need to buy those wipes that James bought it. I want to try them to see how good they are. Yeah, so that was the story with that one. So that's why I ordered the trinocular. But you know the secret, because the picture is good. You want to know the secret? Because also at James the picture could be very clear. There is one secret. No, it's not the lights. So look how looks mine, okay? Let me open that one that I can swing it. So I have here lights. How can I put it that you can see it? Maybe like that, yeah. So I have here 1, 3, 4 lights. This one I can swing them along the way like that to avoid reflections. This one.
Thanks for the sub.
Thank you so much. And this one Oh man, since I could modify my computer from the area, I forgot to make small that one. Okay, I hope that they don't bother. And I have this one that is swinging on the other direction, that I can move the lights in order to reflect. But look at the camera. Look at the microscope. Here, in special here. I have a handle that I can tilt the camera to don't stay exactly on 90 degrees to the table, to stay a bit on a direction. Like that, all the reflection, they don't turn back to the objective. So that's the secret in order to get a clear picture. Not a lot of light. I can also switch the lights over here and keep only one on. It's going the same. It's everything to avoid the reflection coming back. And with this handle, I can make the microscope to stay in 90 degrees or a bit tilted. As you can see now, it's a bit tilted. There you are, Demir. Hi, good evening also to you. So that's the secret to get a picture, clear picture and nicely. Also, James with his microscope, definitely we're gonna get, if he can manage to find an option on his bracket to put the microscope not 90 degrees to the board, to stay a bit an angle. Because I tried this method with lots of types of microscope, like also with the digital one. And also with the one that James sent it to me to try it. Same. 90 degrees angle, all the reflection coming back to the lens. And when you put a bit on tilt like this one, you're gonna get a very clear picture. Well, let's get it out the way from here now. Right. Wait. Why? Right. Now let's go back to the overhead, because I need to give a nice clean with this one to clean all that flux. Where is my alcohol in here? I need to give a good clean with this one and with this one. Kimtank wipes are very good. They are sucking good all the flux around there. I need a new one. I can do a wipe with my hands to all the board. And we become again matte color. Right, nice, no? Nice. Illyria, try to put it a bit not in 90 degrees. Try to put it just tilted a bit, so you're gonna see that from very, very clear that you have now become more clear. Just try it. You're gonna see, just put it a bit in an angle. It will gonna change from like that to like that. All the situation. Also, this one is doing a nice picture if it's straight, but to get more clear picture, just a little bit tilted and it's going better. Just try it in your own to see if you can manage a way to tilt it a bit, and you're gonna see the difference. Right, where I am now, I'm doing through hole solder coming now. Let me clear also this side of the PCB. Nice matte, yeah, looking good. Clear also my table a bit. And let's start with the through hole components, because now we have through hole components over here. Buttons, the buzzer, switching on and off, battery connector, charging battery, and the microcontroller. Right. Let me get my friend on the table. Let me get my friend on the table. Right, where is the box with all the bits and bobs? My son bicycle. Bits and bobs. Right, so what shall I do next? Next I'm going to do these buttons. So let me get the buttons. Okay, I find this one. So let's start with this one. No, let's do the switch on off. Switch on and off. Switch on and off. Where is in this bag? Where did I put them? Hello. Hello, on off switch. Where, in which bag I put you? In which bag I put you? Where they gone, man? I have it, everything here prepared. What the heck? Here MOSFETs, so I don't need any more MOSFETs. Well, here MOSFETs are there. So I don't need this one, so everything what I still need, only this one and this one. Yeah. Hi Martin. Right, I say that I'm gonna start away with the switch over there. So the on-off switch, I saw it in this bug. Yes, it's there. So on-off switch should be there. But because I'm doing a through hole, I'm gonna change my bit. So I'm going to use this one. Going to use that one. Right. Yeah. Yes. The same issues all the time. Need to hold with the... If there is any reflection, sorry guys, there is no other option for me to do this soldering. Only one tap there, and then I can avoid the reflections. So that's in place, but see, I need to straighten it a bit. So that's why it's good to do just one tack. Make sure the component is staying on the right place perfectly. And once it's there, you can carry on finishing the soldering. Right? Shall I zoom more in? Tell me guys. I can't put this one under the microscope because you will not see nothing. It's too high. I can't put under the microscope. So I need to go like that. But if you want, I can zoom with the camera. I have optical zoom. Yeah, everything is in the same box. I put everything from the project on the box, but I mix and match in the bags, so I was not sure in which bag I put them. So look, it's everything in this bag. Some other extra MOSFETs. This one, I think I have the 0.8 threshold voltage. I have 1.2, another model of MOSFETs, and I have another model of MOSFET, I think 1.8 threshold voltage. Zoom a little. Okay. Something like that is okay? Can be good like that? me pour some lager. Beer, lager, I never know the difference between them. And I'm gonna go quick to check on my little boy and I come back. Alright. Good like that? Shall I zoom more in or it's fine like that? Okay, let's finish all this soldering. By the way, I'm using a rosin core soldering wire, so that's why I'm not using flux. Has plenty of flux. This wire inside is a very good one. It's not made in China. This one, it's goated from the website RS. That's a good good solder. It's not a Chinese one. Right, that is coming next the buzzer. Coming next the buzzer. So positive is the long lead over here. Positive is there. Let's go with the buzzer. Gonna bend a bit to hold in place the component. Yeah. Let's give a tack of solder over there. And I push a bit underneath. And now solder also the other leg. There's the chopper. Right. Beeper is arrived. Next, let's go with the buttons. So these are the buttons. Then I go to solder all the pins in once. Let me just tuck them in place with two solder points, all the buttons. Two solder points, the buttons, and then I go to solder all the pins. So that one. Okay. Have no problem with the Chinese solderings. Yeah, I don't have problem either. I have a lot, but just to tell you, I find that this particular one has more rosin core inside than the other ones. Look, where is my box with soldering? Let me show you. So I have my box with, let me zoom a bit out. I'm gonna come back in. So I have this box full of solder. Have a look here. Okay. So I have this one that is not leaded solder. So this is a combination of I believe, because look also, see how looks, too much light. So I have this model, then I have this model which is very fine, which I use it on James when I repaired his multimeter. And I have another model over here. This is same again, it's not leaded solder, it's SN 03 and 07 copper, I believe. Then we have this leaded solder, this is leaded solder, and this model again, rosin core solder, same leaded solder. Yeah, I have more types, but I say I find that one that has the most rosin inside than the other ones. Right, where I was doing, I went in and I need to give some tacks on it. One there, one there. Forgot to zoom in. Sorry guys. Next ones. Last button. That's the last button, and then I can solder all this in one go. That should be alright. Quick cleaning. Tip wipes is magic. Well, that's looking good. Next I'm gonna go with the charger battery. Yeah, charging battery module, just sit over there. Right. Okay, staying straight and flush to the board. You can solder all the pins now. That one. This one. That one. Chopper. Chop these ones down. A little touch to those. And looking good. Now we need to go to the microcontroller, and we have the microcontroller over there, and the pins are there. So these are the pins. So like that. Gonna just drop that one there for now. Gonna read a bit the chat. I'm gonna have I don't know, what is this, lager or beer? Who can make me understand what's the difference between beer and lager? Yeah, need some oil, man. Actually, grease. I have a fine grease at work. I'm gonna bring it. Thank you. Hello, Kevin. Looks like you are new here. If I remember, your microscope is 1080p. Yes, 1080p. It's 1080p, my microscope. So having it in an angle, yeah. Having in an angle, you definitely improve because the reflection is not coming back to the lens. Kevin, I almost finishing. I still have to solder this one. Then before powering on, just plug the charger with this. There is a small trim pot over there to regulate the output. 5.1, 5.2 volts, because this one you can regulate up to 27, 28 volts with this one from a one cell battery. So from one cell battery like this one, with this module you can have 27 volts. So we need to regulate 5 volts, 5 each, 5.1, 5.2, something like that, no more than that. Once the voltage is calibrated, then we need to program the microcontroller with my software, which I write it. So we're gonna need to flash the program on, give a test, if everything works, then I need to do these last bits to put these ones, and it's ready to go. So you miss all the bits when I was soldering all the SMDs. You miss. Beer tends to be ale. Okay, so now we have three things that I can't understand. So ale, beer, or lager. So what's the difference between three things now? Okay, so this beer, in which category goes in? So it's a Moretti. This one, what is? Yes, my love.
Broke feet.
What happened?
Broke feet.
You broke the feet. How you broke the feet? Show me.
So,
Show me. Show me.
so.
Show me where is broken the feet. It's broken or it's cold?
Yeah,
It's cold. Say hi, guys.
Hi guys, and again.
Say, how are you? I come again to see you.
Yeah, I make her sit.
Did you miss them?
Yeah, I'm sick.
Okay, so let me put here that we can see each other, and you speak with them, right? Tell them something there.
Let's sit, okay?
Tell them.
It's
How are you
down.
guys? What are you doing this evening?
You sit down now.
You have a good weekend? Ask them, die.
Yeah, I've always saw you. I saw you.
Yeah, Isaiah.
I saw you how.
Okay.
Okay? It's
Go.
you.
Say bye-bye, guys.
Do okay?
Say bye-bye, guys. I'm going to my tablet.
No, go to it.
So where are you going?
Do okay?
No, here I'm working with hot Greto. It's dangerous for you. It's dangerous, believe me, Greto.
Okay, it's it.
Greto, it's dangerous.
No, I'm seeking.
What you are checking there? What you need from under my desk? What? What you are checking under the desk there? Do you think that there is toys? Your toys, look, are they all there on that side? Now, see? You hit your head now, okay? Look,
Yeah.
your toys are down there. If you check something, are there, your toys. It's not in this side. See?
Yeah.
See? You find them. What you looking in that box? That thing is mommy box.
No. She somehow did it.
That's mommy box. I don't know what you're looking in that box, babe.
Yeah. I see.
Oh. Oh, you want a book? You want to read a book?
Did it.
You want to read a book? Because that box is full of books. Mommy books.
No, I want to read it.
Okay, so I don't understand what you want.
Want to read it?
You want to read a book? Okay, which book you want to read?
This one.
This one. Let me take it for you. Which book you want to read?
Read it. Read it.
You want to read this big book? That's not a book. The books is not there. The books is in different books. Are there the books? Look, there.
Huh?
The books are in that box. Look, all the books are there.
Wow.
See? You choose a book there and you can read it.
Okay.
God, thank you. Sorry guys. I hope you don't mind. What micro do you use? Micro. Which microcontroller? Is an Arduino Nano. It's an Arduino Nano. I think is at a 328P Atmel chip. Well, I was doing the soldering on these ones. So let's get to that ones. I might need to put more temperature to these ones. Yeah, it's an Atmel Atmega 328. Let's do a tuck in that corner. Keep my microcontroller down good. Then go in this corner. Go top down. Go in this corner over here. Tap down. Go in that corner opposite there. Sorry, my finger is in the middle. Then I can solder all of them now, because now I can also take it out from there. And if I want, I can go under the microscope. Shall I go under the microscope with that pin? Let's go. Like that we can see which microcontroller is that one. Let's go under the microscope to see which microcontroller is that one. Alright, so I say it's an Atmel 328. It's a 328 chip. Let's correct a bit the image. Right. Yeah, and look. how much I can zoom in and out. So let me see if I need to go more up. Yeah, I can zoom so much in. Look, and we can have a good now I can put the lights. Let me just where is my chip there. Now I can play with the lights, bring more lights on exactly on the chip, and we can see better. See, it's an Atmega 328p, as I said before. And now we can solder these pins. Let's solder them. See how much flux core they have this solder. That's why I like it to use this more than the other ones. It has lots of flux on it. Let's do also the last row here. And this is the painful. I don't know where I put my other brush, man. Put it in some other box because it's not in that box where I always keep them. But here I can try with this one, but I don't think so that I have chance on these pins to clean with this one. I'm not sure, so that's why when it's through the pin through hole I prefer more to go with the brush, because this one doesn't, see, start opening and all, and you can't clean anymore with this one. That side also is already opened. That's why I don't like to clean with this one. It's all stay all there, all this. Let's get to my classic way with a brush. Right, looking cool, right? It's looking cool, no? Interesting, you have already 7 LEDs on the PCB of the microcontroller. Yeah, there's a lot of LEDs. There's 1, 2, 3, 4. Yeah. But this one are RGB, so there is 3, 6, 9, 10, 11, 12, 13 LEDs on this board, because this one are RGBs, huh? Are RGBs, those ones. And at the bottom there is another, I think that one is the, how is called that port? Not the I2C port. How is called the other communication line that Arduino has? Has I2C, has the serial, and then there is another one. How is called the other one? How is called the other one? The one with the six wire. How is calling that communication line? I don't have now in my mind. I have a lapsus. Because I2C communication is four wire, like actually 3, ground and the data and clock, and the positive that's in the data and clock on. And then there is the other one that you have five communication lines. How is called that port? I have a lapsus. I don't know. I need to check, but there is that port with more lines. Right. Let's put the Arduino in his right place. Solder it also there. And we need to do in such way that I need to hold it with my finger. Do 2-3 points in the corners. Gonna do this corner over here. Gonna do that corner over there. And now I can go through all of them. Yeah, I can go through all of them. Sorry, this one I cannot put under the microscope because it's too high. We can do an expansion after to see the soldering joints if are good or no. So I'm gonna do the soldering and then we're gonna pop up under the microscope to check the solder joints. Nah, everything is again jelly fingers over here. I'm gonna do this soldering and then we go under the microscope to double check our soldering. Double soldering. Because are very narrow, these pins one next to each other. That's why I'm gonna double check the soldering to make sure that I don't bridge any of these ones. Because here there is lots of pins that I'm soldering. Okay, now lots of choppers. 1, 'Let me try this one. Yeah, he's making a squeaky noise, right? Oh, it's Monday when I go work. I'm gonna get a syringe of the fine grease. I'm gonna bring her home and I'm gonna apply to it. It is making a squeezy noise when I'm moving, right? So I'm gonna apply the same method also here on cleaning, because through hole components the best cleaning is a toothbrush, because otherwise you get all that then to give a touch to all of them, because the finishing doesn't look nice when it's cut it. So a little touch, make them a bit more round. See, that one needs a bit of solder. See, that joint needs a bit of solder over there. No, bridge. Why you don't get soldered, man? Why you not soldering? Why you don't soldering? Sorry if my head is in the way. Well, I can't see from far very well. Just want to give a touch. I'm gonna give anyway also a touch with a little flux to make the solder joints more rounded, more shiny, more looking good. But first let me get rid of these pins over here. And while I'm going to throw this one on the trash, I'm gonna check a bit on my little boy, see what's doing over there. It's very dangerous, hot. Very hot, Greto here. Very hot. Yeah, this one is hot. Soldering. Soldering is hot, Greto. You want to burn your fingers?
Let me see finger.
So, see? Go and play with the tablet is better.
What's this?
Which one?
What's that?
What's this? It's Daddy.
How is this?
It's,
Is that?
yeah, it's the same video. Running the same video, Greto. I'm running the same video because I want to make sure if it might happen something to my
What is that?
stream.
What is this?
Nothing, is a tablet, is a not tablet, it's laptop.
Laptop.
Yes, the laptop.
They don't have laptop.
Right, let's give a
Game. This is not the game.
let's give a
This is
little
no
flux and touch on these
This is not the
points.
game. This
Some
is
of the
not
points.
the game. Not the game.
Don't, Creator, don't come here. Go. Sit there, because here I'm working with the soldering iron and it is very hot, Greto. I don't want you to get burned. Okay, let's give a little flux on this.
A boy? Boy? What's this ball? This is swimming.
To make them look nice and shiny.
Okay. I got it. 3, 2, 1, go!
Make them look nice and shiny. Well, that we're gonna do. I'm gonna go with a nice pass on them. That's it. The flux is gone. What the? There's not that much good in this, man. Flux already is gone. Disappeared from the PCB. It's not that good, huh? Flux already is gone. What the heck? No more flux. No more flux. It's evaporating very fast. Evaporating very fast. Let's make them nice and shiny.
Yep. Right. I'm crazy. I want.
Yeah, more flux. We need also in this side. Make the bulb more nice and shiny.
It's night now. You're going to sleep. Daddy,
Uh,
you're going to sleep.
you want to go sleep?
No, no, good sleep.
If you want to go to sleep, we can go, right?
No, go sleep.
You don't go sleep? Why? Why you don't go sleep? Right, let's go sleep.
No. No, go to sleep.
So at what time do you like to go sleep?
No, it's 21.
At 31? Okay. At 31 we're gonna go sleep, no problem.
No, 20 morning.
Yeah, at 31 in the morning you want to go sleep? Oh.
Yeah.
Okay guys, my little boy he want to go sleep at 31 in the morning.
Ah.
31 in the morning, Greta, you want to go sleep then. Alright. We can do 31 in the morning.
It's done now.
We can go 31 in the morning. Oh, I'm gonna say that looking nice shiny blobs. Well, now clean a bit also the table. Zero, Greto. Alright, so I think I need to remove the soldering iron from here.
Okay. Daddy,
Yes, my love.
what's this?
Which one? That one is a board holder. You want to play with?
Yeah, I play it.
Okay.
Dad.
Okay, we put these ones aside. We put all the bits in. Ah, we still have to solder something, guys. See? Why you don't tell me? We forget this one. So it's the battery here connector. Okay, let me get the battery to know the polarity of the beer. So positives in this side. Yeah, go perfect. Is a match one. And this one I need to solder in this part. Alright, I can give a quick solder on that one. Then we can clean the table to run the tests to make sure everything is working good. Okay. That's it. Soldering iron can go up there. Soldering. Quick clean on that. And can get some this one to make, because this one I don't know why, but clean it better also than this, clean better also than the sponge. See, because it's reviolent back to matte color, the PCB. See? Clean the best. This Kimtech wipes when it's coming to cleaning procedures. Right, so where is that? I was having that bug with bits and bobs over here, bits and bobs over here. Gonna need them later after we test, make sure it's working how should. Right, so let's grab one of this one. We apply over here one of this. Like that. We apply one of this one on the battery. Let me see how is the best way in which side to stay the wire. So if the wire comes there, like that. So we apply on that side. Here we are applying this. Somewhere there. Right. They need to mash together, these two. Perfect. Battery is in the right position. Hold in place, doesn't fall. I still feel sticky my map. Let me get a wipe my mat over here because I feel it's still sticky. 1 sec, guys. My little boy has started dismantling something here. Greta, what you are dismantling?
No, I'm fixing.
What you are fixing? You are dismantling.
No, I'm sorry.
Let me try to see if you can fix it back.
I can
Saya.
A baby one. It's baby. Play it. Yeah, play this. This is playing. It's playing, Daddy!
Yes.
It's playing.
Yeah, that's not a plane because you are dismantling. 1 second, guys, my little boy already start dismantling my PCB holder.
Okay? Please.
That's not a plane, that's dismantling what you are doing.
Yeah, I'm not sure how good. Yeah, he's probably it.
What are you doing is call it dismantling, Gretel. Don't go up in there. See, Gretel, you leave it like that, the Gretel. Daddy needs to fix it. Don't touch it, huh? 'Cause, don't touch it, Gretel. I need to fix it. Now you dismantle it. You broken it because I don't know why you needed to open those stuff.
What?
All right, they go to check your tablet. What's going on with your tablet? Check. No tablet. All right, just stay here, but find other things to play, Gretel, because that one you broken it already. I need to fix it later on. You want popcorn? Okay, can you bring that let's go to bring that one. I'm gonna give you some popcorn there. Okay, but close there. Close there. Don't open there. Right, let's go for the popcorn. Come on. Come here. Come here. Come on. Greto, bring that one here. Greto, what happened? Okay, I'm gonna clean, don't worry. Right, I'm gonna clean the mess, don't worry. Come here, let me put.
Oh no! You
Right,
put
clean.
feet
Right,
one.
give me this.
Huh?
That's it. Go.
Bleh.
You're gonna make a mess. Where you want the popcorn?
No, I want to eat.
Where you want? You want to sit here on the table? You want there? Okay, go there. Up.
Yeah.
Go up there.
Cover.
Alright, sorry guys. Sorry. Yeah, it was better popcorn flash. Yeah. My little boy, he loves popcorn. Alright. It's time to run some tests for further things. Gretel, can you put the volume low? Please. If you want high volume, go in the other room, please. Okay, let me help you with the popcorn. Come on. I'm back, guys. I'm back. All right. Let me fill the last beer that I have here. Because it's time for testing. But first need to calibrate the voltage. You need choker when you have circuit board tools. Yeah, I need to fix it because he took out a few screws and now he's moving in all directions. Right, so I need a charger. So let me find the charger, guys. Right, so we have the charger over here. Still sticky over here in this corner. Why? We have the charger over there. Let me find a USB cable, a USB-C cable for charging. Make sure it's charging. What happened, Greto? Wait, what's a second? What happened? Right, let me bring the multimeter on the, where's my box, on the screen, because need first to calibrate the voltage, then program the microcontroller. Whatever I don't need on the table, I'm going to clean the pot, because the other one I'm gonna build it maybe tomorrow. There's no time anymore to build it tonight, the second one. Right, this one goes in the box with the bits for the one I'm gonna build it tomorrow. Right, so far we are alright. The wire back in the box. Who's the preheater with the yeah. No, I have ready-made ones. So I bought from Tesco those ready-made ones. So I give him. Yeah, I have the hot plate, Kevin. I have the hot plate. Yeah. Hi, Dave's. Right, so that's ready there for plug in and measure a few voltages. Let me get my leads over here. Whenever I found it, they're okay. Let's get that one there. Let's turn on. Let me bring the multimeter on the screen, guys. All right. Just 2 seconds, guys, okay? Just to bring on my screen the multimeter. It's alright. What happened here? I'm having problem to connect. What's going on? Right. Should be up and running right now. So is there the multimeter? Gonna bring also the power supply on. Right. Because we need to do 2 measurements, so make sure the off button is down. We plug here and we measure the output. So where is our output? So minus and plus, I saw them there. So we have here minus and here we have positive. Let's see how many volts we have there. 6 volts. So we need to reduce that voltage a bit. And he was nice if I had now 3 hands, you know, with 2 hands to hold the probes there, and with the third one to spin around. So I have another trick how I'm gonna regulate the voltage. So let's measure first. 6.8. So if I go to spin in this direction, let's see, increase or decrease. So increase. So I need to spin in the other direction. So I go in the other direction. Let's measure again. 6.5. A bit more. Let's see now. 6.1, little bit. 5.8, just a little. And let's see now. 5.5, just a little, around 5.1, 5.2 we should be okay. 5.3 is still high. And now we're gonna see that it's less. Now it's 4 point something because I feel that I spin it too much. No, 5.1. Oh, we are imperfect, so this one is perfect. This one is good. Did you see people rebranding Owen? What do you mean rebranding Owen? You sell them same multimeter but in different brand. Right, so there we are all fine. So the voltage is regulated. Now I need to connect to my computer and to program it. So let me prepare everything on the screen and bring them also to you guys to see the program, because now we have all the lights on over there, playing lights over there, the microcontroller. So let me bring in the screen my thingy over here. So what we have here. Alright, so I need to bring one thing. So let me bring a window capture, create a new one, and what we want to capture, this one. Okay, wheel might be quite big. I need to make it smaller, so let me make it a bit smaller. Right, like that we can see also the Arduino on the screen, also the program. So let me open this one to make it here different size. So I'm gonna do it like that here. Now from the screen I can move it, not this one, this one, this one, this one. Can move it there. I hope you can see what is written over there. That's the software I write it on. So which port is now? Which port is this one now? Oh no. Let's see which one is disappeared when I disconnect. So if you have sharper eyes than me, tell me which COM port is disappearing and appearing over there. 14. Is that 14, no? That appear and disappear, right? So COM port in, so that should be my Arduino. So now they need me to select also the board. It's nano, is already there selected. Serial port. Let's go to Arduino. Arduino. I need the nano one. Nano, where you are, nano? This one is already there. Okay, this one. Right, now we need to verify is done, and now we need to upload. So let's upload. Done compiling, uploading, done uploading. So now we should see if it's working. So we need to unplug from here. Okay, let me just close this one. So we need to unplug to do the reset. We need to turn on. Right, increase these ones, and working fine. Yeah, it's increasing. It's increasing. Testing all the buttons. Decreasing. Decreasing also this one. Decreasing. Boom, and stop cycle. Yeah. So all working. Now I need to see there with the multimeter to see if it's switching off power that come from the power supply. Or let me solder those two, because those two I need to solder, and I need to solder with different things. But so far I think if you want to see how it's doing, you just watch my previous live stream, and it's doing exactly the same. Exactly the same is doing, because I can measure the voltage on the gate. So let's measure the voltage on the gate of the MOSFET, and if it's pulsing, that's mean the MOSFET is working. So where we have the ground, because I have negative, the common negative is this one. No, this is an isolated negative. So common negative should be this one on the top. Common ground, yeah, common ground is at the top one. Right, so I can easily put this one here, like that. Hey. And I can measure the gate. Okay, so let's turn on. Let's increase in max. Start the cycle. Right, and the gate of the MOSFET is just right there. So it's going up the voltage, then it's switching off. It's going up, then it's switching off. It's going up, switching off. Well, the multimeter is not that fast like the MOSFET, but believe me, the MOSFET is really fast. It's cutting automatically. If you want, I can connect the oscilloscope, and in oscilloscope you're gonna see the pulse properly, how go fast. James, good night. Have a good one. Irelia, good night. Have a good one. Yeah, so it's working how should. Well, so it's working how should. And I think I will close my stream over here, because soon my wife needs to come as well, home as well. because it's done. And the second one I'm gonna do it tomorrow on my own at home without streaming. I hope you enjoy, guys. I hope that you feel it well watching me building this one for some subscribers that they asked me if they wanted to have it to see how they doing on them labs. So I'm building one for Martin, if is Martin here to watch. So tomorrow I'm gonna build yours, Martin, because tonight I built the one for Adrian. There is one guy that also sent me an email last night from Scotland. Sent me a mail that he want to see it, to try it. And I asked him, you want a kit to assemble it by yourself or you want ready assemble it? So he said that he wanted assemble it. Adrian, Martin also, he wanted assemble it, so tomorrow I'm gonna assemble his one. And maybe next week I'm gonna ship them. Next week I'm gonna ship them. What else was there? The last chat popcorn, about my popcorn that I gave to my little boy because he loved one. He loved the popcorn. So Dave said kids need too much attention for YouTube live streams. Yeah, what to do? In the evening my wife, she's working, so I'm at home only with myself and little boy, so I need to look also after him, and in the meantime also I can stream. And if you don't mind to see him around here or see me leaving the desk and going to check on him, it's fine for me. So yeah, Adrian, you're gonna have it this one next week, ship it. This is for you. The one for Martin, I'm gonna build it on my own tomorrow. I was thinking that maybe I'm gonna manage to build in both of them tonight. If I was doing the same technique like I did already a video when I built first one with the solder paste, like that I could in the same times put them on the hot plate, both boards and all the components was soldering in once. But I asked the guys how they want me to do it, and they want me to do it with the soldering iron, so I did it with soldering iron. A part of the MOSFETs I needed to do it with the hot here because you have that big part of connection over here, and with the soldering iron you'll not do good connection, because that connection needs to be good one, because you have a big ground plate over there that help to dissipate the heat, because these MOSFETs, imagine, they are working the hardest one because they are sending the voltage straight away into the short. They know already that where they go the voltage that passing through, they know that is where it will gonna make them heat up. So if they don't have a big ground plate around, and you can see it's full of it sees here where is it's all around this camera. I'm get confused. So yeah, oh yeah. So here I can see lots of vias, because I have double-sided from this side to this side. That is like acting like a heat sink for them, because they working hard. They know that the voltage that goes through them, the current that let them pass, they're gonna go straight away into a short, and they need to have a really good contact with the board. So that's why I did it with the hot here, to make sure that they are staying good contact with the board, like that the heat will gonna dissipate fast. Guess he could add a little heatsink. Yeah, you could add those. You know, there is those heatsink with double-sided pads that you can stick on them. Yeah, you can do, but no need, because they are working in parallel. So imagine is a MOSFET rated to 80 amps. So imagine two in parallel, they can handle 100 amps without no problem, barely to get hot like that, how they are built. because these MOSFETs are rated to 80 amps and 30 volts. So in parallel, they are working both of them in parallel. So they will gonna handle at least 100 amps. I'm sure they will gonna handle 100 amps in parallel. Definitely gonna handle. Okay guys, any other questions? If anyone wants same to try it, I say drop me an email, because we need to chat in private about, don't share here addresses where to ship it and some. So drop me an email. You find it on my YouTube channel info. You find my email over there, and we can arrange. I say I still have, so I have this one that goes to Adrian. I have the one that I'm gonna build tomorrow that goes to Martin. The one that goes for James is a DIY kit. He will gonna build it by himself, so it's already bugged there. And I have one PCB left for now, until I will gonna modify, because I find very hard to solder these ones, this connector there. So I think I'm gonna modify the PCB. I'm gonna use the same connector, just with the screw connector also in the bottom. Let me, I was talking, but I will not show you what I'm talking about. Let me just, so practically these connectors down here, they're very hard to solder and they melt. First time when I built my own, I broke out 3 pairs of connectors. So I'm gonna redesign the PCB, and I'm gonna use also here, I'm gonna use these round ones with the screws, because I did design this PCB, the first one, to understand what's the difference between these two types of connector, and I understand the screw ones are better. And I'm gonna need to eliminate the diodes from here on the next design PCB. And I'm not remember who suggests me to add a switch also for the beeping. Maybe someone they finding annoying the beeping, and they can switch off the beeper with the switch. So I'm gonna add another switch for the beeper to can switch it really off and on if you want beeping or if you don't want beeping. And yeah, if anyone has a 3D printer and can design a nice case around it with access to the buttons and to the USBs, we can make it a better design and a better product. Okay guys, that's all what I have to say. I hope you enjoyed this evening with me. I'm gonna have still a little, just this beer to finish, and then I'm gonna, when the beer finish also the live stream. Okay. Good night. Good night, James. If you going to sleep, good night. Okay, yeah. See you later, ice worms. I squish worms. Yeah. Alice Slout Lager beer, whatever it is, I don't know. Good night, Kevin. Who else is there? I'm gonna say to everyone good night. Have a good weekend too, because still there is tomorrow. And see you on the next one. Bye bye guys.